Okay, hello everyone. My name is Scott Grizzard from the University of South Florida. This is Calculus. It's 11 a.m. This is Quiz 6A's review. Just to let you know, the AC guy is here. Yes! He is installing the AC in the hallway behind me. You may hear him doing things. He is very important for my life, so, we're going to be okay with him making a little noise if he so desires. How's everybody else doing? I'm getting AC, so I'm like super excited. That's getting fixed. Yesterday, I don't know if you saw it, but last night, or yesterday evening, some people were having trouble with one of the quiz problems and one of the web assign problems. So I did post another video on YouTube with another example problem. So if you haven't seen that yet, please check it out. Okay, so let's jump right in with this quiz. Are there any questions before we begin? Oh, and as usual, we're on Twitch and on the Blackboard Collaborate Ultra for the quiz review. Okay, so let's go ahead and just get started then. Okay, so state the product rule. So do you have to state all of the things? So let's just state it to begin with. If f and g are differentiable, I discovered the trick to neat writing is you make the thing bigger. It's not that neat, but it looks a little better. If, there we go. If f and g are both differentiable at x, then f times g is differentiable x, and d over dx f times g of x equals d over dx f of x times g of x plus f of x times d over dx g of x. Now, first question I always get, do you have to write that? The conditions. We go back and forth. So the answer is I don't know what will be required on the test. For the product rule, I'm fine with the last line. I'm fine with it written, with the du times v over dx bit. I'm okay with that form. I'm okay with this form. I'm okay with the prime notation. Do you have to state the things up here? Not all. The product rule is really, when people say state the product rule, this is what they usually mean, this bottom part. So if you don't do the rest of it, I'm fine with that. On the caveat that I don't know how, and hopefully by the time the test happens, I'll know exactly how it'll be done. But it may change. It probably won't. We've usually settled on this, but being the final answer. But the whole theorem is there. So if you want to, if the whole theorem is there. Usually we're acceptable with just the bottom part. As I said, I don't know for this semester. How do we feel about that one, 1 to 5, stating that nice little theorem? Let's see, multiple choice. Let's see, 1, 2, 3, 4, 5. Start. Okay. Quotient rule. If, now this one has two conditions. F and G are both differentiable at X, and if G of X does not equal 0, then F over G is differentiable Okay, well, it's not really helping my handwriting, is it? No, I actually think that's making it worse. Okay. And again, this is the important bit with the caveat that sometimes that fact, the g of x on the bottom there, that other condition. Now, these are nice little problems for true false problems. For example, I could say, okay, so first, let me go ahead and do the true false. Let's see, multiple choice here. Stop. Perfect. Quotient rule. Okay. So these are nice problems, especially the fact that these are one-way conditionals. For example, these are nice true-false problems. And that's how, I'll even put that a warning. Warning, these can become nice true-false problems. So let me give you an example about that. So let's suppose f is not differentiable at 0. But g is. Could and then say then f over g, I'm sorry, not f over g, f times g is not differentiable at 0. And the answer to that is true or false. What do we think? Well, the answer is false, because consider f times g. Consider f of x equals the absolute value of x, but g of x equals 0. Right? So I multiply 0 times the absolute value of x. That's just the flat line. And that's perfectly differentiable at 0. So they aren't, if I don't meet the conditions, I can't say anything. Right? Now, let's do another one. Suppose f is not differentiable at 0, but g is. Then fg is differentiable at 0. And this is also false. Oops. This is also false. Consider the absolute value of x, f of x equals the absolute value of x, and g of x equals 1. Well, I multiply 1 times the absolute value of x, I get the absolute value of x, which is not differentiable at 0. So the point is that if you don't meet the conditions, the theorems are silent. I can't say either way what's going to go. So how do we feel about that 1 to 5? So if I don't meet a condition, it just means that I can't tell. Right? It's not the case that FG is differentiable. I just don't know. It could be. So that's just a thing to keep in mind, that these things can become true-false problems pretty easily. And I'm personally not that cruel. But, I'm not writing the test this year. And they actually are good conceptual questions. I think they're mean. But, they are what they are. All right, so what was the rabbit for the product rule? So the product rule was that the rabbit was that 0 equaled f of x plus h, or sorry, negative f of x plus h, although you can write it in either order, g of x plus f of x plus h times g of x, right? How do we feel about the rabbit? 1 to 5. Okay. Oops, that's the wrong one. This is the one I want. Okay. Well, no, you don't have to set it equal to 0, but the point is that it is 0. You're adding 0. That's the point. But yeah, just the statement, the negative f of x plus h, g of x plus f of x plus h, g of x is fine. I'm on board with that. Okay. All right. So what's the rabbit for the quotient rule? Well, it's 0 equals negative f of x, g of x, plus f of x, g of x, or vice versa. I don't remember how I did it in the notes. So I could actually look it up. Hold on. Let's see. The answer is I did it the other way in the notes. And this rabbit is actually in your textbook. If you open up your textbook, believe it or not, we do use this thing. I know I put pretty notes, so I don't open this much. But if you open it up to section 2.4, if you have a physical textbook, it's page 109. If you don't have a physical textbook, that's it's not that. The g of x plus h, and there it is right there. You add it to the top So if you go to section 2.4 where the quotient rule proof is, you add that to the top. Once you take a common denominator, you just add that to the top. And then you can split it out and get that subtraction. That's the other rabbit. So let's go back to polling. Multiple choice. You have to stop it. You have to go back to the polling and then stop it to keep your options. So again, I made an announcement about this. Is it going to be on the test? They have been. I don't know what they're going to do this semester. That seems to be a common theme, right? But I don't know what they're going to do this semester. I'm sorry about that. I'm used to being the person writing the tests, and this is weird for me because it's not me this semester. So usually I'm like, ready with the answers. This is going to be on the test. Yes. Really? And then if you bother me about it later, is this going to be on the test? I go, it is now. But, I don't know the answer to the question this semester. So, I do know what we've done in the past. I do know kind of what they want to do. But I don't have all the answers this semester. Sad. Okay. If you don't understand those rabbits, please, or what the point is that that's the little piece you have to memorize. You won't have to understand the whole proof, kind of memorize a little bit of a statement, but the rabbit is that chunk right there in the middle that you like. I never used the rabbit for the quotient rule. I had to go look it up. It doesn't matter which one you used first or second. It matters in the sense that the negative, when you're doing the proof, the grouping is that the negative term goes with the one before it, and then the positive goes. So it's easier to group if you have the negative one first. But you don't have to. Okay. Moving on with life. Again, I don't know if it's going to be on the test or not. All right, D over D alpha. Here I'm going to use the product rule. Now, I want to be very clear. When I do this, whenever e to the x or the exponential function is involved, I am always super careful with it. And I mean super careful because this little thing is its own derivative. So it's very likely that you forget stuff when e to the alpha. You lose track. Something distracting happens during the test, or dog barks or something, and you're like, what? And then you lose track of what you did the derivative of and what you didn't. So, especially when it comes to e to the alpha, I always write out everything. So I'm going to do the whole thing here. D over D alpha of e to the alpha times ln of alpha equals. And now I'm going to be very careful with my product rule. I'm actually going to write it out. Plus e to the alpha d over d alpha ln of alpha. Please do not skip that step. It's a very natural thing to skip, especially if you're trying to move quickly. Whenever e to the alpha is involved, please don't skip something, because it's very easy to mess them up. That's just e to the alpha. I carry my baggage. This is e to the alpha times 1 over alpha. And I am done. Don't simplify it. Don't factor it. Don't do anything. If I'm looking for, roots and things like that later, in module 3, maybe I'll factor something to get that. But for this, for the moment, we're done. Okay. All right. So 1 to 5, how do we feel about that one? Let's see. This would be question. Is it 3 only? Yeah, question 3. Let's see. Stop. Update. No, it didn't do it. Did it do a new poll? Hold on, it's not telling me. Oh, sorry. Try that again. Okay, I don't know what was going on there. Just a little buggy. So, okay, so if you wrote the answer, remember you have to do it in a way that communicates what happened. And here's the problem. If you don't do this step, now you didn't have to write the PR, but if you don't do this step, what happened to this e to the alpha? It's not clear that you took its derivative. So there is communication there. Somehow you have to indicate that that's what you're doing. And if you didn't do that, it's incorrect. Especially with these e to the x bits. Okay, so do you lose points? Not if you do it correctly. Okay? If you do it correctly, you're fine. If you mess it up, so if you simplify correctly, hey, more power to you. But, if you mess up the simplification, you're going to lose points. On WebAssign, the answer is actually wrong, which is annoying. You lose all the points on WebAssign if you factor wrongly or do some little thing wrongly. All right, on this one, f prime of 4. Well, that's 1. How can I tell? Well, 2 up, 2 over. Or you can do, if you want to, you can do f of 6 minus f of 2 over 6 minus 2 equals 4 minus 0 over 4, which equals 1 this week. All of those are good answers. Pick one. What is g prime of 4? Well, g prime of 4 equals 0. How can I tell? That nice tangent line. All right, compute f prime, fg prime of 4. Now, if you get a question like this on the test or in general, and these are not like out of line questions, because especially when you're dealing with like products of things, when you're doing chemistry, sometimes these things kind of show up like this, where you've got data and you know it's the product or whatever. I'm sorry, g prime of 4. Thank you. So what I would, and these are nice conceptual problems, hint, hint. So I don't know if it'll show up this year, but they have in the past. Actually, I think I stole this one off an old test. So, what am I going to do here? Well, when I do these, what I do is I write out all the pieces, okay? So I'm going to actually write what f of 4 is. F of 4 equals 2. And I'm going to be very careful, because remember, these things are not always drawn to the exact same scale. I try to do it when I write them, but g of 4 equals negative 4. F prime of 4 equals 1. G prime of 4 equals 0. I'm just going to write those things out. Now, the reason I want to do this is two reasons. One, I've got them close. Two, if I mess this up, right? If I accidentally said 1 instead of 2, the grader is going to take off half a point, right? Because then I'm going to have the formula that I actually used right next to it. So it's obvious that where I made my mistake was reading the graph, right? It wasn't messing up the formula. So that's the difference between no points and bad you, right? So, just keep that in mind, that if you do this, you get, you could save your butt. All right, so what I'm going to do is f g prime of 4 equals, and I'm just going to write the product rule. F prime of 4, g of 4, plus f of 4, g prime of 4. Now, why do I do that step? 1, communication. 2, what if I mess up when I'm pulling the numbers into here? if I wrote what I did here and I wrote what I did here, if I accidentally write g prime of 4 here, that's an oops. I knew it was supposed to be g of 4. I just misread. Okay? If I don't write it there, then the grader has no idea of the fact that I knew what I was talking about and I just messed up, and I lose all the marbles. And then I'm just going to write it. 1 times -4. I'm going to be very careful with that -4 because I know it's multiplied. Plus f of 4, which is 2, times g prime of 4, which is 0. Which equals -4 plus 0, which is just -4 today. Also, if you messed up here, you wrote 2 times 0 and then said it was 2. Okay, so the graders are going to have a little laugh, which is, it's better this year because they aren't in the grader group. But, they made that mistake too, so you can laugh back. But, it's not a major, it's wrong. You'll lose a point, but you won't lose everything. Okay, the next one, I'm going to do the exact same thing. I've got my numbers already written here. I probably wouldn't copy them again. But we've got a computer for a reason. Okay. So now I'm going to write f over g of 4. Now, warning, D and E could be an answer to one of these questions. I would never do that to you, but just, keep in the back of your mind that sometimes D and E is a valid answer for these types of questions, especially with the quotient rules in play. All right, so I'm going to write out the rule. F prime of 4, G of 4 minus F of 4, G prime of 4 over G of 4 squared. And then I'm just going to read them off. So this is 1 times -4. I'm going to be very careful with that -4 again. Minus, this has got to be 0. Who cares? But we'll just do it like that. Over this term here, g of 4 is -4 squared. So that's going to be -4 minus 0 over 16. Or I could have just canceled them because it's the same number. Now it's going to be -1 over 4. Assuming I did the math right. Okay, so how do we feel about that question? That one's a long one. Okay. Did the video I posted, by the way, help? I hope it did. Kind of give you a hint about what it was looking for. As I said, this is also the way that these tests get very cumulative very quickly, right? Because if we put this on the test, this reading off the slopes of the tangent line was a test 1 skill, and now we're asking you test 2 stuff about it. So this is the way that these tests, even though if you hear that they're not cumulative, they are. I think this semester we actually explicitly made them cumulative, but they can get cumulative very quickly, simply because the skills from test 1 get asked on test 2 simply because of the nature of math, right? It's cumulative. All right, are there any other questions? Okay, before we start the problem set, so the problem set, if you've seen it, it's set up for the class right after the chain rule. So the way this, you don't care, but the way that this would normally be is that I usually would do the chain rule first, and then we'd get to that problem set. But with the COVID thing, the now the lectures, which are supposed to be you're supposed to watch beforehand, are now in the evening, and it's all mixed up. So we haven't done the chain rule yet, and that's supposed to be done before the problem set, but that's okay. Let's just look at it very quickly. So the chain rule looks like this, okay? I've got this kind of thing, G and F are two kind of functions. And I can think of this, so the example would be f of x equaling sine x squared, okay? So let's just do the chain rule real fast, and you'll see what goes on here. Now, this right here, if I do this, right? So let's invest in X's journey here. Okay? This is X's journey. So X comes along, and the first thing that happens to X when I plug it in is I get squared. So X gets squared, and then it gets signed. Okay, so 1 to 5, how do we feel about X's journey there? How do I do this again? Oh. Okay. X is getting squared, and then it's getting signed. So what I'm going to do, and this whole thing together is f of x. Okay? But what I'm going to do is I'm going to break it up. And I'm going to make this equal to u. And this right here, the very end, is equal to y. So what I have now, if I want to account for both of these, what I'm going to do is account for the change here and account for the change here and multiply them together. Okay. So here's how it works. D over dx, note the x of sine of x squared. All right. Now, what I'm going to do is I'm going to name something u. Let's move this over. No, the Q is talking to me. The Q is talking to me. All right, so I've got d over dx of x squared. Now what I'm going to do is I'm going to name something u. So notice that this here, I'm taking the derivative in terms of x of something in terms of u. I can't do that, but I can take the derivative of u. So what I'm going to do is I'm going to call this u. Okay. And then I'm going to change the variable by which I'm differentiating. And that's the key. That the thing that the chain rule allows you to do is change the variable by which you are differentiating. And that's the key. Okay? So now what I'm going to do is I'm going to take, okay, now I've got this. Now I'm going to apply the chain rule. And what I'm going to do is I'm going to take d over du of sine of u times du over dx. Okay? Now I'm going to evaluate the first one. The derivative with respect to u of sine of u is the cosine of u. And then I'm going to say that's d over dx. And now I'm going to substitute in my u. So I'll make this just a u period here. Okay. It's not u squared. U equals x squared here. Okay. So now I've got d over dx of x squared. Well, now the derivative here and the variable here and the variable here match. So I can take this derivative. So I'm going to carry my baggage. This here is baggage, right? My ex-fiance left me. Well, she didn't leave me at the altar, but she left me holding honeymoon tickets in my hand, right? So I have got baggage. I don't have to deal with her anymore, but I have to carry that baggage. Okay? In this case, the baggage was, a kind of a wedding gift that had to be returned too. So it was nice luggage. Anyway, this right here is baggage. I have to carry it. Now I take the derivative with respect to x of x squared. I get 2x. Now, because I made u, I have to sub u back in. And that's my answer. Because I made u, I have to simplify that. So 1 to 5, how do we feel about that? Let's see. And we're going to do it a bunch more. As I said, we're going to do a bunch of these. I'm going to have a whole lecture on this. So you will see it, me do it a bunch of times. But just, the first impression of it. Oh, yes, this will be posted in notes. There'll be an entire tonight. There will be an entire thing on this alone, right? So at the 7 p.m. lecture, hopefully we'll have AC by then. Yes, this will all be done tonight. I will do tons and tons of examples. I will do double chains. I will do lots of stuff. And the quiz for Wednesday is already posted. So if you, that was a common request that you felt you didn't have enough time between Monday and Wednesday. Of course, I didn't post the quiz for today until yesterday, which was a problem, but that was a common request. So I'm trying to get them up, both of them on the weekend before, and I'm going to try to get them up even earlier than that. That was a common request. I'm trying to do that. Okay. So if you will please, I'm going to stop the stream. Goodbye, Twitter. And we're going to break out in groups.